Hello and welcome to our next lesson in this topic on light. So in the previous couple of lessons we've looked at what light is, we've looked at reflection and we've looked at refraction. Today I want us to have a look at how the eye detects light and how cameras detect light. So by the end of the lesson you should be able to describe how the eye works, you should be able to explain how a simple camera forms an image, and you should be able to compare how the eye works with how a camera works. In your books, you should be writing the title, The Eye and Cameras, as you would do any other lesson. You should put the date in the top corner. And we will use the online chalkboard, as we have been doing for the previous few lessons. We will be referring back to this, but these are your learning objectives for the end. So today's lesson's title is The Eye and Cameras. So, what I'm going to do is I'm going to first of all take an image from what we had just, and we want this one. In fact, we'll have this one first. Okay, so on the board is a image showing how you see objects. When you look at an object, there is an image formed on the back of the eye on a part known as the retina. Okay, so we can start by saying that when we look at an object, comma, an image is formed on the retina of the eye. An image is formed on the retina of the eye. And we can define the word retina because it's very, very important. Retina. The retina can be defined as a special layer of tissues, or of cells, sorry, not tissues, a special layer of cells at the back of the eye, that detect light. So on this diagram that's here, this yellow layer on the back of the eye is the retina. Those are special cells that detect light, and we're going to talk more about those in a moment. So just to make this a bit more clearer, your retina, if that'll work. Is it going to work? No, we can't see it, so I'll do it in orange. It's the best I can do. Your retina is the layer in yellow shown on this diagram, okay? And this contains special cells that allow you to detect light. Now, light goes through what's known as the pupil of your eye. The pupil of your eye is a hole through which light can enter the eye. So your pupil, which is our next keyword, is a hole in the front of the eye, that allows, help if I can spell that allows light into the eye. So the hole in the front of your eye is your pupil, and that allows light to enter. So the light that's reflecting off this object is entering the eye through a hole known as the pupil. Now, your iris is what controls how big your pupil is. So our next keyword is the word iris. Iris, I-R-I-S. And your iris can be defined as a muscle that controls how much light can enter the eye through controlling the size of the pupil. So we can say that the iris is a muscle that controls the size of the pupil. It controls how much light can get into the eye. Now, just to show where these are on the diagram, I'll use this colour here. Your iris is shown here on the diagram, and your pupil is shown here on the diagram. Now, your iris is specific to you. No two people have got the same size iris or the same patterns in their iris. Okay, that's why we can use certain scanners to determine the identity of someone. Your iris is only specific to you. My iris in my eyes would be different from the iris in your eyes. Therefore, we can use eye scanners to determine people's identity from their iris pattern. In the middle of this diagram, that would be the pupil. So this black hole here would be the pupil. That's what lets light into the eye so that the light can hit the receptors in the retina so that you can see. So our next bit that we need to label is the cornea. The cornea. And we can define the cornea as the transparent outer part of the eye. So it's the transparent means see-through, transparent outer part of the eye. Now, the cornea on our diagram, the cornea is labelled here, and your cornea covers your pupil. It also covers your lens. So we can just add underneath here by saying that the cornea covers the pupil of the eye. So it covers your pupil, okay? Now, when we see an image, we say that the image made on the retina is upside down, okay? So the image made on a retina is upside down, and your brain flips it back round the correct way. So we can write down that images on the retina are upside down. And the brain flips them so we see them normal. A word that we could use here is the word inverted. The word inverted means upside down. So inverted simply means upside down. So, when we look at an object, an image is formed on the retina of the eye. The retina is a special layer of cells at the back of the eye that detect light. When light comes off an object, it goes through our pupil. Our pupil is a hole in the middle of our eye that lets light in. And the iris controls how big the pupil is, so how much light can be let through. There is a special transparent layer known as the cornea, which covers the front of your eye so that it doesn't get damaged. When the light hits the retina, the image is upside down. The optic nerve sends a message to the brain, which then flips the image the right way up, and we see what we need to see. So the optic nerve, before we move on, I'm not sure if I'm going to have space, but the optic nerve, I'm going to have to use black. The optic nerve sends messages to the brain from the eye. Okay, so we've got all the parts of the eye here. The final thing we need to talk about, and I do need to clear the screen, is I want to focus on the retina. Okay, this is what I want to focus on. Now, if you haven't got the information down off the board yet, you can pause the video and make sure you get them all down. And I'm going to refresh the screen so that we can talk more about the retina. So, if we reset our screen back to black, we get this. I'm going to add an image because it will be useful. Add image. We want the iris, which I've been referring to. I'm going to make it a bit bigger. Oh, not smaller, we want it bigger. And we can put the subheading, what happens in the retina? So, what happens in the retina? Question mark. Okay. Now, your pupil lets light in. Your pupil allows light to go from the outside into your eye, and so that the light can hit the retina. So we're going to say that the pupil allows light into the eye comma, so that it can hit the retina. Now, just for your benefit, because we've got this lovely diagram here, and it would be a shame to waste it, this part here, this middle part, is your pupil. Okay, the black part is your pupil. The outer part that is coloured is your iris. So this part here is your iris, and your iris is different for each individual. So that's your iris. Okay. Now, on your retina, there are some special cells known as photoreceptors. Photoreceptors. And that can be our next key word. Photoreceptor. P-H-O-T-O-R-E-C-E-P-T-O-R. A photoreceptor is defined as a specialized cell that detects light. So, a specialized cell that detects light. Oh, I forgot to spell detects. Do you know what? I'm going to rub all that out. That detects light. Okay. There are two types of photoreceptor. There are rods, which are sensitive to movement and dim light, and there are cones that are sensitive to bright light and colour. Okay, so we can add underneath here that there are two types of photoreceptor. In the retina. Dot dot. We've got rod cells, which are sensitive to movement and dim light. To movement and dim light. And we've got what are known as cone cells. Cone cells. And cone cells are sensitive to bright light and colour. So cone cells are sensitive to bright light and colour. So the reason we can see lots of different colours is due to these cone cells. If we didn't have cone cells, you wouldn't be able to see colour. People who are colourblind are missing some of these cone cells or have more of one cone cell than they do another, and therefore this affects how they see different colours. Now, once light hits the rod and cone cells, a message is sent up the optic nerve to the brain, where the brain can make sense of it. Okay, so we can say, and I'll put it in red because it's important, once light hits the photoreceptors, comma, a message is sent up the optic nerve to the brain, which makes sense of what we're seeing. Which makes sense of what we are seeing. And I'm not going to have enough room. What we're seeing. So, what happens in the retina? The pupil allows light into the eye so that it can hit the retina. On the retina, there are photoreceptors. These are specialised cells that detect light. There are two types of photoreceptor in the retina. We've got rod cells, which are sensitive to movement and dim light, and we've got cone cells, which are sensitive to bright light and colour. Once the light hits the photoreceptors, a message is sent up the optic nerve to the brain, which makes sense of what we're seeing. So, you should now be able to tell me how the eye works. We now need to have a look at how a simple camera works. Okay, so if we can go back we can refresh our screen. If you didn't get all those notes, it doesn't matter. You can pause the video, you can go back. That's the beauty of us learning in this way. It's one positive way of doing it as a video. So we can now put the subheading, how do cameras work? So, how do cameras work? And we can give it a question mark, because it's a question, and we can underline it. Now, cameras produce an image just like your eye, okay? A perfect example, or a very simple way of showing how this works, is with use of what's known as a pinhole camera. A pinhole camera. So that will be our next keyword, pinhole camera. I'm going to write it down in 1 second, just give me a second. So in green, pinhole camera. A pinhole camera can be defined as a simple camera, made of a box with a small hole at the front, made with a box with a small hole at the front and a screen at the back, and a screen at the back. And luckily, to help us with this, I've got an image, or I've got a diagram showing what a pinhole camera looks like. It's a drawing of one, okay? So if we add an image, we've got a pinhole camera here. A pinhole camera looks, it's getting smaller, we want it to get bigger, like this. Okay, if you've got time at home and you've got the stuff, you may wish to try and make one of these. They're very easy to make. What you need is a box. You need a piece of photosensitive paper or tracing paper glued to the back of the box. You also need a little tiny hole the size of a pinhole on the other end of the box. There would be a lid on this, and you would look from this way. So if you're going to make one of these, I'm not saying you've got to, but certainly if you did make one and showed it me on the Google Classrooms, I'd be inclined to give you a star award, I would imagine. Your eye would be here like this, so that's how we show an eye in physics. And you would watch the screen, you would need to cut a hole out of the box, glue the tracing paper on, have a pinhole on the other end, and it will make an image on this tracing paper. So we can say that, and I'm going to change the colour so that it looks a bit more colourful, that light enters the pinhole camera through the pinhole like how light enters the eye through the pupil. Through the pupil. So light enters the pinhole box like it would through the pupil of an eye. The image is formed on the screen exactly like it would be formed on the retina. So we can add to this, we can say an image is formed on the screen as it would be formed on the retina. As it would be formed on the retina. Okay. Now the image is a real image because you can make it on a screen. However, the image that you see in a mirror with your reflection is not a real image. What you see in the reflection is a virtual image because it cannot be put on a screen. So we can use a keyword here and we can say a real image is defined as an image you can put on a screen. An image which can be shown on a screen. Now, this is different to a virtual image, which we spoke about in the lesson on reflection, okay? So we can add to this, we can say underneath that the image on, or the image made in the eye or in a pinhole camera is a real image. Is a real image. Okay? And I'm just going to add in red, because it's important that you understand the difference. I'm going to say over here, we discussed virtual images in the lesson on reflection. In the lesson on reflection. I'm just going to put an arrow over to here. So, how do cameras work? A pinhole camera is a simple camera with a box that has a tracing paper on one end and a pinhole at the other. Light enters the pinhole exactly how it would during how light enters your eye through the pupil. The image is then formed on the tracing paper exactly like the image would be formed on your retina. This is a real image because the image is formed on a screen, whereas when you look at reflection, that is not a real image because it's not being formed on a screen, it's being reflected from a mirror. So, for the final part of this lesson, I want to add two images. First of all, I want to add the image that says how the eye sees an object, and I want to make that bigger. It would go smaller, wouldn't it? It always does. We want it a bit smaller than that. We don't want it that big. And I want the other another image added, which is entitled Image Formed with a Pinhole Camera, and we'll make it of a similar size. It will go small first, and then a bit bigger. Okay. In fact, we want it a bit bigger. We can go bigger than that, can't we? So that you can see it. All these images are on the presentation that I've added to the Google Classrooms. So you are welcome to look at them, cut them, paste them, however you wish to use it. And we can label these. We can say how the eye forms an image. And we can say how a camera forms an image. And we've got some similarities, as we said. We've got light entering through the pupil in the eye, and we've got light entering through the pinhole in the camera. We've got light forming an image on the retina in the eye, and we've got light forming an image on the screen in the camera. Now, cameras often contain a film, a photosensitive film, that allows us to use chemical reactions to make a picture. So we can say that cameras use photosensitive paper that uses chemical reactions to make a photograph. But you guys are probably way too young to remember what photographs are, because you're using phones now and you make pictures on your phone. So in a digital camera, there is a grid of photosensitive elements known as pixels, which create an image so that we see the photo. So we can say that digital cameras have a grid of photosensitive pixels which form an image or form a digital image. Right then, I've waffled on for far too long now, I think. If we have a look back at our learning objectives, and I keep going the wrong way, but I did it right this time. You should now be able to tell me how the eye works. You should be able to tell me how a simple camera forms an image, how a pinhole camera forms an image, and you should be able to compare how the eye works with how a camera works. What I would like you to do at this point, I would like you to pause the video. I would like you, if you want, you can use the PowerPoint that I've attached in Google Classrooms to do this. I would like you to have a go at the questions on the board. I'd like you to have a go at question 1. You need to write out the sentences, filling in the gaps. You then need to have a go at question 2 and 3. You must write out the question before answering it. Could you please pause the video now, make sure you've got a different coloured pen, preferably green, but any colour will do, because once you press play, we're going to go over these questions and the answers. So pause the video now so that we can go over the answers in a moment. Okay then, so you should have paused the video. You should have had a go at the questions. Let's go over the answers. So, if we put the screen back to black, because it's easier to see, if we add in our questions. So first of all, I'm going to add the first question so that we can write our answers in. There we go, that's about big enough so I can add to it, isn't it? So, it should read, change my pen to red, make sure I am on here. It should read, when you look at an apple, light reflects off the apple into your eye. The light enters your eye through the pupil. The cornea and the lens focus the light onto the retina. the retina. The light forms a real image. Real image. A chemical reaction produces an electrical signal that is sent down your optic nerve to your brain. Optic nerve to your brain. So it should read, when you look at an apple, light reflects off the apple into your eye. The light enters your eye through the pupil. The cornea and the lens focus the light onto the retina. The light forms a real image. A chemical reaction produces an electrical signal that is sent down your optic nerve to your brain. Let's add the other two questions now. I will keep those quite small because I realise I've made that first question way too big, so we're not going to have much room. So you're going to need to mark this. The second question says, so number 2 says, describe how the camera in your phone is different to a pinhole camera. So your camera in your phone uses pixels. So camera in phone uses pixels. And for your second mark, you needed to say that a phone also stores the image, whereas a pinhole camera does not. A pinhole camera just makes the image live. It can't store it. So we can say that a phone camera can store an image, but the pinhole camera, I'm just going to put PC, in fact no, I'm going to put pinhole. Pinhole camera can't. So those are your 2 marks for question 2. For number 3, this is a 6-mark question, quality of written communication. That's what QWC stands for. It says compare the eye and the pinhole camera. So for similarities, you could have said that they both have a hole at the front. They both have a hole at front to let the light in, to let light in. Another similarity that they have is that they both have a screen that forms an image. So both have a screen that forms an image. Some differences. There's no way of focusing with a pinhole camera. So a pinhole camera cannot focus. Okay. The retina has light sensitive cells. The retina has or photoreceptors, we'll say. Photoreceptors, but pinhole camera does not. Pinhole camera does not. We can say that the eye produces an electrical signal. So the eye produces an electrical signal. but the pinhole camera does not. But the pinhole camera does not. And finally, we can say that lots of people see the same image on the screen of a camera, but only one person can see the image on your retina. So we can say lots of people see the image on a pinhole camera, but only you can see the image formed on your retina. So for 6 marks, compare the eye and the pinhole camera. Just for your reference, I should have perhaps made a little bit clearer that these first two are similarities. So these are your similarities, and these last few are your differences, okay? No, sorry, the first two and the last four. So if I get rid of that, these are your similarities, these are your differences, okay? So similarities, they both have a hole at the front to let light in. The eye has a pupil, whereas the pinhole camera has a pinhole. They both have a screen that forms an image. The eye has the retina, the pinhole camera has a screen. The pinhole camera cannot focus, it's either blurred or it's clear, whereas your eye can correct it automatically. Your eye uses the iris to and the lens to make sure that the image is very clear. The retina has photoreceptors, but a pinhole camera does not. The eye produces an electrical signal, but a pinhole camera does not. And lots of people can see an image on a pinhole camera, whereas not many people can. The only person who can see an image formed in your eye is you. So that concludes today's lesson on the eye and the camera. Hopefully you got a lot away from that. If there is anything you're not sure about, please feel free to put a comment in the Google Classrooms or drop me an email and I will get back to you as soon as I can. So please keep safe, all the best, see you next time.